Hi everyone. In the given problem statement, we have to find symmetric tree. Given the root of a binary tree, we have to check whether it's a mirror image of itself. Let us take this example. We are going to have the root node, which is going to be 1, which is going to have two of its children, 2 and 2. Then the two are going to have subchildren, 3 and 4. And 2 another is going to have children 4 and 3. So here, right, let's say if I place a mirror from 1 to 4, right, the exact same tree is going to get repeated. So this is called a symmetric tree. How to solve it? We can create a function, let's say def st, and we're going to pass in two parameters. So here, right, one we are not going to take, we're going to take the children of it. So here, right, let us assume this one and this tree as two separate one for now. So let's say we can going to pass in p and q out here. Let's say how to pass it up. We're going to call the function st, and here, right, we are going to pass in root dot left and root dot right. So if I'm going to pass it right, so now both of them are becoming their individual trees, and we have to check it out whether they are symmetric or not. So the first thing we can check is that if p is none and q is none, in that case we are going to return true. In case it would be p not equal to none and q equal to none, in that case it's not the same, so we are going to return false. Elif, again elif, if p equal to none and q not equal to none, return false. And at last, right, in case both of them are containing the element, so simply we are going to check the value. So we are going to, let's say, return our function is st. So here we are going to pass p dot, let me just swap it to here because it's a very important function. So we're going to return st and p dot left child of it and q dot, because we are going to match the values, right, because it's a mirror image, right. So what is 2 out here, right, it is going to be the opposite one. For example, let us take this value of 4. Okay, so 4 is the right child of this first tree, but here, right, the 4 is the left child of it. So when you're going to match, right, we're going to send the opposite values. So q dot right and again p dot right, and here it would be q dot left. And we are also going to check the values, because even though the trees are matching, right, what if the value does not match? So it would be p dot val equal to q dot val. So this would be the entire problem statement. So here, right, we are subdividing our entire tree into two separate trees, and we're going to check whether they are mirror image of itself or not. Now let us jump for the Python solution. So the first thing that we are going to do, we are going to create a function. Let's say def symmetric tree st, and we're going to pass in two separate values, which is P and Q out here. And from our code, we are going to return our st, and the values is going to be root dot left and root dot right. Now when I inside the function, we are going to check if P is none and our Q is none. In that case, we are going to return true. Only thing that I made a mistake, it will be P. Now another condition, elif P is not none and Q is none, return false. Elif P is none and Q is not none. In that case, we are going to return false. Else return st. Here it would be P dot left with Q dot right, and again we are going to call this function P dot right with Q dot left and P dot val equal to Q dot val. Now let me run this code. As you could see, it ran successfully for the public test cases. Let me submit it up. And as you could see, the submission was successful and it is beating 100% of the submission. So our code is pretty efficient, and if I look into the complexity of it, it is going to be go of n because we are traversing all the nodes one time, which makes this code pretty efficient. That's all for this video. See you in the next one.